Header length?
Yes, sir. Sir, it's visible. The screen is visible.
Yes, visible.
Yeah. Okay, sir. Open model file. This model 16. Okay. Okay. So this is what exactly we have done yesterday.
Correct.
Okay. Now I will be adding few more things to this.
Krishnapad, I have sent you on screenshot. Have you seen that?
Yeah, this image, sir, worker
Ah,
image.
ah,
Mostly you have selected this option. When you click this work pool,
mhm.
here there is an option, move freely within area.
Okay.
I hope you have changed this one.
Okay. Always it should be
Move
move
freely within area.
area. Huh? Yeah. At the same time, just now again I have cross-checked it. It's working fine now.
Hmm.
Previously it was coming the same error.
Yes, sir. Okay,
Yeah.
fine. Now, let me reset the simulation. So we have done missions, conveyor, these things. I hope we have done the robot also, sir, right?
Correct. Robot also done,
Yes.
and I think some
Uh,
assembly part should be
yes,
done.
assembly at the same time, buffers. So we have done the
Ah,
buffers. Yes, buffer done.
correct.
Uh, fine.
In buffer, it's a storage device. So basically, yesterday we have seen in
Hmm.
buffer we have stored the parts in a linear. Means
Hmm.
we have stored the parts in an inline. Okay.
Huh.
So can we assign the parts by using overall that buffer? Is it possible?
Sorry, sir, I didn't get you.
So yesterday, if you use the buffer, no,
Huh.
so then the all the parts will be stored in inline in the
Ah.
same line. Okay.
Ah. Huh.
So can we separate those
Sir,
the
actually,
line?
yes, it's a representation. That's it. Buffer is having
Okay.
that representation like one part should be holded. So if the
Okay.
capacity is increasing, it should be in line. That's it.
Okay.
Okay. In actual, it may differ, but according to the plant simulation, according to this model, the part was
Mhm.
at the center only. They have designed the model like this. So that is why
Mhm.
the part will be at the center. We can't change that one for a buffer.
Mhm.
Okay. Now today, so we have done all these things. Next resources. I will tell you the AGV, sir. AGV is the one part, main part.
Mhm.
This one, where is this? Automated guided vehicle, AGV. For this, I'm just deleting this one. That's it. I'm just deleting the drain from all the mission, from all the process. This chart will be placed here. This chart will be placed here. If at all I want to use a transporter, then mandatory thing is, let me. So here, this is the process and AGV. If I click AGV and place here, it won't be placed. For using a AGV, automated guided vehicle, we definitely need some important things. Okay, that is nothing but first thing is a track, which is a automated guided vehicle is nothing but it is a vehicle which is controlled by on its own, which means it is having a trace, so that it is following the trace and it will move based upon the trace we have given. So for using this AGV, first thing that is needed is a track. So this is what a track is. So we need to click this one, and so where exactly we want. So from this, I hope from this place, first, second.
I think it's angle. It's not one. Okay.
So is it visible?
It's visible, but it's showing slowly.
Yeah, might be internet, sir. From morning
Uh,
onwards, we are taking sessions. Might be internet. There is a delay in the internet.
okay.
So we are taking like this. Once I
Mm-hmm.
was done, this is like a open. Whenever I
Mm-hmm.
am using an AGV or whenever I want to use this type of guided vehicles, then the track should be closed.
Okay.
Otherwise,
That
what?
yellow.
Yes, yellow. This is called track. This
Okay.
should be closed. Otherwise, what will be happen? The part will start here, its motion,
Mm-hmm.
and it will reach the final destination, and at the final destination it will going to halt.
Mm-hmm.
So if it is a cyclic one, if it is a connected both ends, then what will be happen? It should run on a cyclic way.
Correct.
Continuously it will going to work. So
Mm.
then in this connection I am going to use a connector from this joint to this joint. Now it was a closed loop. Just a second. Clear, sir? This is a
Uh-huh.
closed and I have used a connector here.
Can you please show me again this track?
Yes. We need to select the track application.
Okay.
Just like the conveyor, there will be a pop-up that will be enabled here.
Mm-hmm.
So don't worry about this, just leave it. And
Mm-hmm.
we need to start the track. So where exactly we want the track? First we need to select the first point, then second point. If we want to stop, then press escape, it will be stopped. Otherwise, if at all we want to continue, we can drag the mouse. If at all I want a curvature, then I need to hold the control.
Control and you can slice. Correct.
Yes.
Okay.
Now it was done. Now it
Mm-hmm.
is a open ended. Now I want to close it. If at all I want to use the same one, I mean a single AGV, and it should be cyclic, then I can extend it same by clicking
Mm-hmm.
this object and M manipulator. So the modification tool will be opened, manipulators, and it will be connected automatically. Else I can directly connect this end with this one, so it will going to connect.
Mm-hmm.
Two different forms. Now I have given the track. Now what I need to assign? I need to assign AGV. So for
Mm-hmm.
that, this user interface mobile units, in that there is this transporter. I can pick this one and I can place here. It was placed, but it is not the correct method.
Mm-hmm.
For that, definitely I need a source. Okay. Here actually we are using this source for this mission, which is like an input. Similarly, we are using another source here. This source is like a AGV source, or it is like a parking area where all the AGVs will be stored. It's a storage area where all the AGVs will be placed. From
Mm-hmm.
this station, the AGV will come and it follow the route. So I am
Oh,
using this AGV, and I need to connect this with this track, AGV and track. Now I have given relationship with source and track, and this track is a cyclic one.
mm-hmm.
Now here this track, if I open this one, there is one option here, mu part, which is this is I mean this source is producing part. Here I don't want part, I want a AGV. So
Okay.
directly I can go to this select object or open object. If I click open object, sorry, select object, then there will be a pop-up will be opened, container part transporter. AGV is nothing but transporter, so we need to
Correct.
select transporter and OK. So now the MU is changed here. MU
Mm-hmm.
is nothing but mobile unit, mobile unit. The mobile unit is
Mm-hmm.
changed here to transporter. This is one method. Else there is another method. For that, directly open this mobile unit and
Mm-hmm.
drag this one and drop in the source.
Okay.
If you click this one, see here.
Correct.
Previously it was part. Now when we drag and drop here, so automatically it will connect to transporter.
Mm-hmm.
Now done. If I reset it and if I run the simulation,
It's crashing, no?
yes. At the same time, I don't want these many number of AGVs. For
Mm-hmm.
that, I need to enter into here. Here, instead of interval adjustable, I need to enter into number adjustable. How many
Okay.
AGVs I want, whether I want one or two, that depends upon the model. If I want one, then I need to click one, apply, OK, and reset the simulation and run. The AGV is running on the track continuously.
Mm-hmm.
Based upon the application, if at all I want to stop it, so where to stop, when to stop, that will be defined in the next step.
Okay.
Now I have assigned the AGV and AGV is working perfectly on the track. Now it was done. Now here I am dragging a little bit and I want to use a robot. I want to use a robot. So my application is the robot will pick the part from this mission and it will place at this AGV. This is what I am assumption. Now for that I need to connect this mission with this robot. So I have enabled a connection. Whenever a part was ready, this robot will pick a part from this mission and it will place part to this conveyor. I mean to the AGV or to the track. Now I have assigned the input. Now I need to assign the output. For assigning the output, one important thing is, so we need to hold the robot, drag and drop on the track. There is an icon.
Okay. Once you connect
No
from
sir.
machine to robot, we need to
Yes.
drag and drop on the
Yes.
track, huh?
We need to select the robot
Okay.
and now see once dragging it, there won't be having any other mark other than this arrow mark.
Mhm.
Now when I choose this to the track, automatically another pop-up will be raised. There is a shortcut will be opening.
Mhm.
I hope it's visible, sir. Beneath the arrow mark, beneath the arrow, there is
Correct.
a some
Understood.
small arrow is there.
Correct.
Which means if we place here, so which means a relationship should be started. Now
Mhm.
I want to choose where exactly I want to place, whether I want to place at this corner or at this corner or at the center. I need to choose. Why? Because this is like a sensor we are
Mhm.
providing. If we choose release here, it will ask me four different things. What exactly I want to do? I want to pick application or a place, or I want to load unload. So what
Mhm.
exactly I'm doing here? So now here I am picking part from this mission
Mhm.
and here I am placing. Clear sir? Picking a part
Okay.
from a mission and placing
Correct.
on the edge. So if I click OK, then see there is a sensor that was created here.
Mhm. There is a picking portion, huh?
Yes, this is called as a sensor,
Sensor.
which
Yes.
means this AGV will come here and it will stop here. Previously, what happened? The AGV will continuously run. Why? Because it doesn't have any sensors. If I place a sensor here, stopper, simply I call it as a stopper. So what will happen when the part comes, when the AGV comes here, automatically it will be stopped. When once the loading was done, automatically this sensor will open this one and again the robot, again the AGV will move its direction.
Okay.
Now, instead of this one, again I am placing this one. Again I am picking and dropping at this location, at this corner, placing. Same it will ask, pick part. Now I am using some unload option, load or unload. So I am using load. Again it will be sensor is placed. This is how
Mhm.
we are going to place a sensor. So we need to pick and we need to hold the robot and drag and drop on the track.
Mhm. Okay.
Now it will be asking what exactly you want to do at the sensor, that it is asking. Now I have defined. Now let me reset the simulation and run the simulation. It doesn't stop here, but it stopped here, which means
Mhm.
here we need to assign not just a second. If at all I want to delete it, click and delete.
Mhm.
Same, click, delete.
Okay.
Now here pick and drop. So here I want to use load or unloading option. So which means I am picking a part from a mission and loading on the AGV. So this is like a read and trial. Sometimes sometimes place will going to work, sometimes load will going to work. That is why I have defined two different sensors to check which exactly working in this application. Now load is working, so load. Now a sensor is created here. Again I want to check. So I am resetting the simulation and running it. Yes. The AGV is coming here and it was stopped.
Okay.
Here the mission, the process is common. The process is working like this. Once the part was done.
The simulation is not happening, no?
Yes sir,
Happening?
it's running sir.
Okay. Okay.
The robot is picking a part and it is placing on the AGV here.
Hmm. So instead of drain, we will be using this one,
No,
right?
no, 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 sir.
AJ, huh?
For material handling application, if at all I want to move my material from one area to another area, I mean one
Right.
production line to another production line,
Mhm.
different process going to happen. Maybe one production line is at this station and another production line is at the far,
No, that is
might
correct.
be at the here. Using a conveyor will always be difficult. Why? Because there will be a lot of obstacles in between.
Mhm.
At the time, I will be using an AGV and I will be giving a track.
Track. Track is must and
Yes, track. Yeah, at the end, maybe I see like this. I will be selecting M, and here I will be
okay, good.
placing like this continuously. I mean from starting to stop. Just a second. I need to hold here. Yes.
Instead of modifying,
Hmm.
shall I use one more track? Shall I attach one more track to that
No, no, no,
closer
sir.
track?
It is not possible. Closed.
Oh,
One closed means one closed only. If you try to
okay.
overlap it, it won't take. It won't be considered. If at all you want, you can delete this one and you can draw the newer one. But
New
here
one.
there won't be possible. Joints won't be
Mhm.
possible. Now it was fine. Now see, sir. Reset the simulation. I am pressing M. Yes. I'm increasing the speed. Sir, I hope it's visible.
Correct. Visible.
Yes. Now the AGV will follow the complete path which I have defined. Now see, sir, here.
So it unloaded also.
No, sir, there are parts here.
Mhm.
Now the operation was paused. The operation was halted.
Mhm.
Why? Because here we have picked the parts and placed on the AGV. And
Mhm.
AGV is having parts and AGV is now rotating. I mean AGV is now moving. And here
Correct.
there is no any loading station. From here it was collected the material and it need to dispatch that material. There is no any other device here to dispatch it. That is why the robot will be
Correct.
kept like this. And the parts is
Mhm.
on the also on this AGV or kept like this. Now, whenever I use a robot here or whenever I use a track, then they should be having two things, for one for input, one for output. Let us say this as input.
Mhm.
Here I am giving, here I am assigning some work to AGV. At the same time, I need another robot to correct the material. If this is the application, I want to correct the material and I want to dispatch it to the mission. Then I need to use another robot here. Let me use P. Okay. So I'm using another robot directly or else here, and I'll be using a conveyor. Yes, it was connected, and yes, sir. P. Now I have defined like this. Same. I need to drag and drop on the this one
Track.
track.
I need to define unload. No.
No, sir. Yes, unload. Correct. Here we need to go for the unload. So
Mhm.
if we use load here, then we need to use a unload. If we use place,
Correct.
then we need to use a pick here. So unload
Okay.
option. Okay. Now it was defined. A sensor was defined here.
Mhm.
Now the simulation will work. If I run the simulation,
That option must and should they have to develop. As I told, no,
hmm,
they have to attach the
see
track
sir
wherever
here.
they want.
Now it was running.
Correct.
Once the
Correct.
loading was done, again the parts will be entering to next subsequent stations. It will be entering like this, and again second part,
Mhm.
second loading will going to happen here. There
So
will be
simultaneously it will do. It will
yes.
perform.
Once it was done, then automatically it's a cycle. So
Correct.
whenever we are going to stop, it will be stopped. Otherwise, it will be continuous. This process continuous movement.
Mm.
Now the robot will again collect the parts from the station.
Again, it will
Again, it
unload.
will
Yeah.
run. Continue. It will run. Like I can increase n number of times. This is one cycle. Maybe sometimes
Mhm.
what will be happen? There is a station here, and there are three more missions here. From this, I need to collect the material. I need to dispatch here. Again, I need to collect material from this station somewhere, and it need to dispatch here. Like multiple stations will be there, where these AGVs will going to collect that multiple stations.
Okay. So I have one more question, Krishna Prasad. So
Yes.
now you have created the tracking boundary here.
Yes.
Okay. So inside that, can I draw one more closing boundary?
Yes, sir. You can define, but again, what will be happen? See, I can define like this also, overlapping one.
Full circle, like that.
Yes, yes, yes. I'm doing it, sir. I can do like this. See, once it was done, then I need to close it.
Mhm.
Here, same closing application was done. Again, I need to use a source. This is my source. And in that source, I need to drag and drop this AGV. It was dropped. Now I need to connect this AGV with this connector. Okay. Now, I need to use another robot here to pick and place some object. So I will be using some maybe okay. I have defined the source here, and there is a mission here. From this mission, uh, just as here there is a source, and I was directly connected this with this one, and there is a conveyor. Now these three are connected like this. Now here I need to use, and I am using another robot, where the main application of the robot is picking a material again, picking a material and placing on this one. See, I will be using this one here. I will be using load application. Okay, now a sensor was created here.
Mhm.
See, now it will pick and it will place here. I need to go for number adjustable and one. Okay, transporter. Now I want to place them like 1 2 3, control C, control V, and I will be using at this one at the center. Now I'm dragging and dropping here another connection from this station to this station. Here I will be using one more robot, and this robot is connected directly with this one to this one,
Will
and
unload. Yes.
yes, here it is unload option. Okay,
Mhm.
now I have defined here. There is
Mhm.
one internally and there is one externally. Let me check whether it will work or not. So let me run the simulation. See here. Two simultaneous operations. Once it was done, this part will be collected. It will be collected and placed.
Mhm.
Again, it will be reaching to this one. It was halted, and the process is
It's
continuous. Even though it
this
is,
is
yes, it is in the center also, it will going to work.
correct. Correct.
Yeah. Why?
Because I
Because
wanted to see the collision if there is collision
no, no, no,
happening
sir. They
or
won't actually.
not.
This is a plant simulation 15, which I am using 15.2. In
Mhm.
there is a newer version that is 2201. In that they
Okay.
have implemented this option. If the robot
Okay.
collision will also automatically detect. So if two
Good.
robots are coming in opposite direction or side by side, then automatically the speed of the AGV will automatically reduced.
Reduce.
It
Okay.
will be reduced. That is the newer update that was released.
Mhm.
So maybe in this software it will going to happen in this version, but in the present version it is not going to happen.
Mhm.
Which is the one advancement which they have involved in this plant simulation
Okay.
software. And like this, simultaneously multiple operations can be done.
Mhm.
If see there is a pick and there is a place here. If I want, I can directly alter it. Just a second, it was done. Like I need to, if at all I'm using an AGV, if at all I'm using a AGV and a track, definitely there is a need of this robot, sir. Without
Correct.
robot we can't use this one. It's a completely automated process. The
Mhm.
material is collected from the conveyor. At the same time it will be distributed to the next AGV. Only here human can't work. Whenever, if at all I want to assign a human, it is not going to possible. This AGV will going to work with respect to robot only, which is a completely automated process, so that we are going to use robots here in this application. Clear, sir? Hello. Hello, sir. Okay, fine, sir. Okay, okay, fine.
Hear me, Mr. Prasad? Sorry for disturbing.
Yes, sir. Yes, sir. No problem. No problem.
Uh, Sometimes my laptop get hanged sometimes.
Okay, sir. Sir, it's common. We are using these type of software, so automatically the
Correct,
laptop will be hanging very huge load.
correct, correct.
Okay. So that is what I am saying here. If at all I want to use a human for this AGV application, which is not possible.
Okay.
Okay. Now, so this is the process. So just practice the AGV. There is nothing much complicated. We need to give the track. First thing is we need to
Yes.
assign a track like this. Whatever the
Right.
track may be, we need to assign a track, and it should be closed. Even though it was open like this, don't worry. So just close it by
But
using a connector.
uh-huh.
Okay. Now I
Okay.
we need to assign a source. Why? Because from the source is like a hub. Source is like a hub
Okay.
where the part is coming, where the
As you
transporter is
said,
coming.
it's like kind of parking.
Yeah, it's like a,
What
it's
it was
kind of a
something of
parking.
parking. Yes.
Yes, mobile unit. And for assigning a AGV, we need to drag and drop this AGV here.
Inside. Okay.
Yes. Once it was done, we need to recheck it, open it, and here there is a transporter option. Once the transporter option is enabled here, fine, we can work on it.
Where transporter? Which
Last, sir,
there?
MU.
Okay. Okay.
Previously, if at all we use a normal source, it's like a part. So
Part.
whenever we
Okay.
drag and drop this transporter on this source, then automatically it will be converted. And next one, we need to change it to number adjustable.
Number.
Based upon the number here, 1 I am using, so 1.
Okay.
Now this application I am using 2. Same thing. If at all I have given 2, then if I run it, 2 AJVs will come.
Correct.
So
But
once
there's no use, no? To but
sir, based upon the application, based upon the, I mean, material movement. If the material movement,
continuously.
yes, if the material movement is more or large, now in this application there is no need of 2. Why? Because very slow material movement is there.
Correct. Correct.
Here in this there is a lot of material movement. Now here I am assigning 2. Okay, reset the simulation here.
Correct. Continuously. Yes.
Continuously.
Yes.
Now 2 can
Correct.
work. Now what will happen if I give 3? Like I can check this logistics also. If I
Correct.
give
Correct.
3,
Again, there's an one truck will be waiting behind that. If you use it.
yes,
Correct. Correct.
like I need to check. So up to 3
Understood.
I can use. If at all beyond 3, what will be happen again? There will be a waiting phase will be there. Unnecessarily
Correct.
one AGV is additionally usage for this application. Like I need to
Correct.
check on this thing. At the second one is, so we need to assign the number of AGVs here. Once the assigned was done, then we need to make a connection between AGV and the
And
track.
track.
Yes.
Yes.
Now it was completely organized. Now we need to assign a robot for doing the application. For assigning an application, so we need to click and place a robot here. Now here we need to
Right.
assign two different things. One from for output or for input. So if at all I want a mission or a conveyor, let us say a conveyor. From this conveyor the material is coming. Let us example. It's not at all correct. No, I'm not going to do that. Here there will be a additional source and there will be a mission, and from which there is a conveyor. Now I am having this one, so I need to connect it. Whether what is the type of operation I need to do, whether I need to collect the material from the AGV or I need to collect the material from conveyor, I need to check that. If it is in reverse, then I need to connect these two things. Now the connection was established, then I need to create a sensor here. For creating a sensor, so drag and drop this robot on the track wherever we want. Then we need to use the options, different options, load, unload, like this. Here I am going to use load option. So I need to pick. So when I check this one, when I run this one, so if the AGV is going to stop, then it is a correct application. So we are going to pick a part and placing here. Once it was done, same, one application is not at all correct. So if there is an in application is there, at the same time there should be an out application also. That out application should be this one.
Understood. Correct.
Yes, it should be like this. This is out application. Now here I need to use a robot to collect the material. So here I am placing, here I will unload, and I need to select this with this one. Done. If I run the simulation, if I increase the speed, that's what the AGV is, sir, completely. Now it will move continuously in the plant. Wherever we want, we can define the track. That's it. Where it will automatically go to that location.
Understood.
Okay. Now I'm saving this model. Model 4. I will be starting a model 5. Now model 7. Now I will be deleting everything. Now one more important thing. So there should be a minimum thing, mission and a mission. Here I am going to use these many missions. Now my input is 1 and this one is 1. Now I need to connect all these things. Here I am using just assumption connection only, not conveyor for time constraint. I will be connecting each and every process in detail like this. Like I have created a complete different creation here, divergent or convergent creation. From this source, the material is going to dispatch to different sections. Once it was done, now I need to run the simulation. The material simulation is running. Here I want to run the simulation for 2 hours. So let me increase it. 2 hours was done. There is one thing I want, if at all I want to check the mission characteristics, then definitely I need to go for chart. So I need to pick and place the chart here. I need to select all the missionaries, drag and drop here. Okay. Sir, is it visible? Sir, is it visible? Hello. Oh, sir.
Yes.
Sir, where you have missed? I don't know. I'm just running like this.
Oh, no, you have assigned all the machines
Yes, I
and
have
you
sent a
have
message.
connected.
Yes, I connected with a
Connected.
chart.
No, I
Now,
have not seen this chat.
just a chart only, sir. Just I have started a chart
Okay,
and I
okay,
have sent all the missions to this one.
okay, okay.
That's it. Now I'm running this simulation and I want to run it for the maximum is 2 hours. So I will run it and I will check. So this is what exactly it will be. There will be a lot of blockages will be there because of internet connectivity. At the same time, here we are using direct connectivity connectors. If at all I am using a conveyor, maybe this blockage will going to reduce. Okay. Now there is one more method to identify these things. To identify the blockage as well as waiting phase. For that, I am resetting the simulation. There is one option here. In the tools, there will be one option that is called as a bottleneck analyzer.
Mhm.
If I click, if I drop here, just like the chart, I need to run open or else double
Okay.
click this one. So then you will be having this option analyze
Okay.
open. So you need to do for analyze.
Mm-hmm.
Okay. Now reset the simulation and run the model. Open. Yes. So there are the bars visible. Yellow and directly yellow bar, green bar.
Correct.
Green is like working, yellow is like blocking. Green is
Blocking.
working and
Yes.
this is blocking. So everywhere
Correct.
there is a small space of waiting also. This is
Waiting.
why there is a
Waiting.
gray.
Correct.
So that is why this every here there will be having no any blockage. So that is why green in color. Like directly by using this bottleneck analyzer, we can check where exactly the process is failing, where exactly the process is having loads. For that, I will be explaining you again. Reset. I'm deleting this one. So for this, I need to go to tools section and there is having a bottleneck analyzer. So I need to select the bottleneck analyzer and I need to drop here. So I need to place in the frame. So once I have placed it, then I need to double click it. So which means I need to open it. Here there is an option analyze. So we need to analyze the model. So first we need to click analyze. Then
Okay.
reset the simulation, run the simulation.
First analyze, then reset the simulation and
Yes. Once the simulation was done, once the 2 hours of time was done, then we need to select open.
open.
Then there will be a dialog box will be opened. We need to select close and we can check.
Okay.
This is how the representation will
So
be.
by using this bottleneck, we can optimize, no? Where
We can direct,
exactly?
yes, we can directly see this is all these stations, one, two, three, four, all these stations will be having a
Yes.
bottleneck.
Yes.
Now whether I need to change the layout or I need to use some material handling devices or I need to increase the length of the conveyor, like there will be having a lot of methods to do this thing.
We need to do a
Modifications we
modification.
need to do, but here directly there will be having representation, which means these many missions will be having bottlenecks
Okay.
directly by the process, with which instead of going for a chart, I can check this by using chart also. But in chart it is like a additional representation, whereas
Hmm.
bottleneck is directly represented on the mission
On the
itself.
machines itself. Yeah.
So if there will be having 100 missions, then all the bottleneck will be visible on the missions itself.
Correct.
We'll call as a this is called as a bottleneck. Now we need to reduce this yellow. That is what exactly we'll call as a bottleneck optimization,
Okay.
which is like, so now we will be having different alternatives. Here I am using a connector. Now instead of a connector, I need if I use some conveyor, then what will going to happen? If I increase the length between these two things, then what will going to happen? Like I can check on different scenarios.
Got it.
Clear, sir? This is called as a bottleneck analyzer, with which I am going to check the complete bottleneck of the process.
Hmm.
This is one of the key important topic. This is a bottleneck analyzer. Simple thing. First, we need to create the layout. Once the layout was done, we need to import the bottleneck analyzer and we need to analyze it. And then we need to reset the simulation, run the simulation completely. Once it was done, then we need to click on open. So
Open.
it will be
Yes.
opened. Now with this, we can showcase them. If the industry is there, if some industry has given the project, then we can directly show him that in your plant, in the running plant, this is the bottleneck you will be having. I mean, this is the blockages you will be facing while running the model. So by using this plant simulation software, you can do this. At least I can try for minimizing all these bottlenecks by increasing the distance between these two missions, or by using a conveyor belt, or by using a random AGV, or by using a robot. So different alternatives there for minimizing this type of bottleneck here,
Okay.
blockage.
Okay.
That is called as a bottleneck analyzer, with which I am going to showcase what is the productivity and how exactly my process will be running. I can directly showcase this one. Fine, I am resetting this one. There is one more thing here. So instead of that one, I will be giving, sir, one more thing. Till now we have worked the missions without any failures, right?
Hmm.
I haven't assigned, as of now we haven't assigned any failures. These
Correct.
missions are running for 100% efficiency, I mean 100% occupancy. But in real there is no any mission that is running 100%
Hmm.
efficient. So
Hmm.
at least you should be having 5% of failure rate, so
Correct.
that we have to assign each and every mission a failure. For that, so we need to enter into mission statistics. So which means we have to enter into mission characteristics, that is double click on the mission
Okay.
characteristics. Here in this time tab we are going to change the process. Here everything is a 10 seconds of processing time. Here I want to
Yes.
change this also. We have forgot that one. So 60 seconds is the processing time. Now I need to give different times and I can check the bottleneck analyzer, so that the bottlenecks will be differ from one station to another station. Now I have defined, I mean I have changed the time here. There is a second option, setup. Setup is like, for some CNC missions, if there is a change in part, changeovers, if the changeover is there, automatically we need to select the fixer over the mission wise or a mission base. That is called as a setup. How much time it will take for a setup? So if at all I am setting a new mission, then how much time it will take? If there is that is there, then we need to select this one and we need to define time. If I don't have any setups, then no, don't worry, don't disturb this one. Then the third one is a failure. In the failure tab, so this is one of the important topic. In the failure tab, so always we need to select this active button, which means we are selecting the failures as a one of the important thing, one of the key thing for a mission. So it was enabled. Now I need to select new. Clear, sir? Again I'm telling you,
Clear, understood. Actually,
mission.
why we need to give a failure? Why?
Sir, if at all I have purchased a mission, maybe that
Okay.
mission will run continuously for
Mhm.
100 days or for 100 parts. Maybe after
Okay.
that time, maybe because of some inspection, maybe because of the tool damage, or maybe
Okay.
because of some coolant purpose, the mission will going to stop for 2 minutes or 3 minutes or 5 minutes. Maybe it is
Mhm.
for a manual inspection or it is like a failure. Generally,
Okay.
we will be considering as a failure only for that 5
Mhm.
minutes or that for the 10 minutes. If it is for inspection purpose, we will call it as a manual inspection. If it is automatically generated by a mission, then we will call it as a failure.
Okay.
So let us consider all these
We
missions.
assuming we are giving the
Yes,
failure, no? This
yes, we
assumption.
are assuming that mission should have at least some 2% of failure.
Failure. Yes.
Yes.
Okay.
So we are opening this one and we need to enter into failures tab. In the failures tab, we need to select this one. We need to enable this one. Then we need to select new failure. Then additional pop-up will be raised. In that additional pop-up, so don't disturb all these things. These are all completely sir, if at all I have explained you, there will be a lot of theorems involved in it. So directly I will explain this one. So this is
Okay.
95%, which means out of 100 percentage, 95% availability is there. Only 5 minutes of breakage will be there. If at all I want to run this model for 100 hours, out of 100 hours, 95 hours will work and 5 hours will be the failure rate. For different failures, the failure rate is not like a constant one. Maybe it will be like 0.5% at the starting and 0.2% at the third part, 0.5% at 50 percentage. Like after completing the 100 part, we will be having 5 percentage of error together. That is what exactly this 95 percentage availability means. Now, MTTR is like mean time to repair. If whenever there is a repair happened, so how much time it will take to repair it, how much time to restore it, that is MTTR. Here I am, if it is having default is 1 minute, maybe I can change, if at all I want, I can change it to 10 minutes also, which means whenever there is an operation, whenever there is a failure is there, it will take 10 minutes. It will take 10
Okay.
minutes to
In
rectify.
the simulation,
Yes.
the machine will be idle for 10 minutes, right?
Yes,
If we
mission
give
will
the
be,
failure.
if a failure has happened, so now the mission will be ideal for 10 minutes, which means to get its working condition back, it will take 10 minutes of time.
Okay.
Okay, now we have given these two details. Here there will be a drop down down in that simulation, operating and processing time. Simulation is like, so whenever we are starting a simulation, which means this one, it is represents with this one. So 00, you will consider from this 00. That is called as a simulation time. I mean, whenever a machine was operating, whenever the complete process is starting, so automatically from that 00 point, this 100%, 95 percentage calculation will going to start. There is one more thing here, operating time. Operating time is like this machine operating time is 1 hour or 1 minute. So in that 1 hour, there is a process of 55 minutes will going to work and the rest 5 minutes it will going to fail. That is called as a operating time. Processing time, sorry, that is a processing time. Operating time is like a complete process. If this complete process will take just like a tag time, so in the tag time what will happen when a part entered here, so and the part exiting together, in between it will take some 1 hour or 2 hours to complete the complete process. Out of the 2 hours, the 5 percentage will be the loss, 5 percentage will be the failure. That is what exactly these three. So for explaining these three, there will be some sort of equations that will be involved, which is not at all I am explaining you sir right now. So that will be time taking one completely. So in general, we are using simulation as a default one. Why? Because whenever we are starting a simulation here, see this is a simulation. So whenever we are starting a simulation with respect to this one, I mean at 000, it will be considered 000. If I start here, so automatically this will also start. Simultaneously it will going to work. So based upon the simulation time, it will going to work. Now apply. Okay, now I have defined. Let me check it. Now I am increasing this one. Yes. Now I want to check directly the bottleneck. I can directly show this chart also. Where is this failure? Which station I have designed the failure? Okay, I haven't set the okay.
If it show red color, then we have to consider that it's a
Yes.
fail.
Yes, there is a failure. I don't know, sir, but why it is not showing. Setup time, failures, and in the failure, edit, simulation time. I am selecting it to simulation time only. Maybe I will be considering it to 90 percentage of availability. Apply. Okay. Okay. Running and resetting. It is not at all showing. Open. Analyze. Failure. Edit. The simulation time. Out of simulation time, I'm checking this time processing time. I'm checking. Okay. Apply. Okay. Analyze. Open. Still it is showing white in color. Maybe I have to disable this one. Okay. Reset the simulation. It is not showing now, sir, but I don't know why it is not showing, but it has to show. This is which station? Station. I can define this also. Open this one. And failures, active, new, MTTR, failure, simulation time. Apply, OK. Apply, OK. Reset the simulation. I'm running the simulation, resetting it. Yes.
And now we can see
Yes.
a fail.
Time. Previously, I have utilized the time is 2 hours. Maybe because of the time, it was, I mean, the failure rate is not that much visible.
Uh-huh.
But now I have run the simulation for 10 hours. Now in the 10 hours, it was visible. Maybe
We'll
out of
change it
10.
to 10 hour now.
Yes. Now I have changed the simulation to 10 hours so that it is visible. Now it was started visible in both stations.
Correct.
If I click this one, show analysis, now here, there is a red mark also. In the bottleneck analyzer, directly I can calculate this one. Previously, see, for this mission there is no any failure. So why? Because we haven't assigned any failure. We have assigned a failure for this one, so it was enabled. Similarly to this mission also, if I double click this one, failure, new, 95% and 1 minute, apply, okay, okay, and we need to reset the simulation and running it. Now third mission failure is also considered. Now this will be the realistic model. So this is how we are going to run the simulation. Now, sir, if we consider this as a simulation, every machine will be having one failure. So now every machine will be having failure, blockage, waiting, green. Now we need, there are two things mandatory. Failure is mandatory, we can't change the failure. At the same time, we can't change this green also. So we need to reduce this yellow phase. So that is what exactly our role as a plant simulation expert by using this software. So by anyhow, by using conveyors or by increasing the length of the conveyor or by placing some other alternative missions or by using some other process, we are going to reduce this blockage to the process. That is what exactly we are going to do in the optimization part. Clear,
Okay.
sir? So initially,
Understood.
first thing is we need to create the layout. The layout creation is like this. Initially, if at all I want, I can directly start with a 2D layout. Once I am familiar with 3D, then directly I can start in 3D also. Like I have shown you the models, and I can after preparing this model, I can connect with by using conveyors, and I need to prepare the layout finally once. Once the layout was finalized, then I need to start work on the optimization part. If I have done these three missions and I need to I started working on optimization, we won't get that optimization result perfectly. So we need to create the complete layout like this by involving whatever it may be, 20, 30, 40, 200 missions, involving each and every mission in the process. Then we need to work on the analysis part, I mean optimization part. If there will be having these many missions, and now control C, control V. Now I am deleting this. Now I'm building the chart, reset the simulation and running the simulation. If I show analysis, this will be like this. Now this is my complete model. In the complete model I will be having this much of blockages. Now I need to start working on it. So if this is the first process, in the first process how to eliminate the bottleneck, in the first three missions how to eliminate the bottleneck, or from the last I will starting work from these two missions, there won't be having any bottleneck. Why? Because it is directly connected with the drain, whereas this mission is having bottleneck. Why bottleneck? Because these two missions will be occupied with some material. Now how to reduce this one? I can use a buffer here. Directly I'm placing and dropping a buffer here. At the same time I can drag and drop another buffer here. So now I will be having two different buffers here. Now let me reset it and I will run the simulation, and once it was done, show analysis. Now see, the blockage was reduced at this station. Like I can map. So from this end I need to start working on it. Now there is a blockage between these two. So this yellow phase is there, this yellow phase is there. How to reduce this one? Maybe I can use another buffer here. Now I am reducing this one and I need to run this one and show analysis. See, the bottleneck was reduced, I mean blockage was reduced. Like I need to work on different aspect scenarios from this end. Like first we need to create the complete model, then we need to work with respect to the model which we have defined. Clear, sir? For every mission, so
Clear, sir.
we need to
Clear.
define this also. Failure is also the mandatory thing we need to define. Next one is, so once we open this one, there will be having important tabs. This one is a times, where we are going to give the processing time. After that there is a failures tab, where we are going to give failures. And next one is like a importer. Sir, can you please unmute yourself?
Hello.
Sir, can you please mute yourself? It is completely disturbing. Okay, thank you, sir. Here, see, in the first one, times, we are going to give the processing time. In the third tab, we are going to use the failures, which is also mandatory thing. Whereas importer, it is also mandatory. Whenever you are going to use an human, then this tab will definitely used. And there is a one more thing here: energy, cost. These are all advanced modeling, sir. So if at all you want to calculate the energy consumption of a mission, then go to energy unit and you need to active. You need to active the services. So once you have activated the services, here you need to click apply. Then everything will be enabled here. So you can define how much while working, how much power it is consuming. So how much kilowatt power it is consuming. For setuping the mission, how much power it is consuming. While operating, how much it is consumption. While the machine is having failure, how much power it is consuming. So standby position mein how much power it is consuming, while offing how much power it is consuming. Like we need to define each and everything here. If default is 1, if at all I can change, I can directly change here 5 and I will be using 2, I will be using 2, I will be using 10 and off. Like I have defined multiple energy here. Change the energies. Okay, now I have defined energy here. So for calculating the energy, just like the bottleneck analyzer, after the tools there will be having energy analyzer also. So we need to select that energy analyzer, we need to drop here, and we can drag here to this one. Energy cannot be executed. Okay, now reset the simulation and run the simulation. Once the simulation was done, it need to show why it is show results table. Have we assigned this only? Energy, yes, we have assigned. Then show chart. Chart is not visible. Drag and drop here. Yes. Reset. Yes, now it is visible. Just like the chart, so we need to select each and every mission, we need to drag and drop, which means for running this mission for 10 hours this much of energy is consumption of energy is this much. Like we can calculate the energy consumption also. Like for each and every process we can define. Now this process having this much missions is having, so I need to select each and every mission and I need to give all the energy data and I need to drop here, so that all the data will also be saved here. Now, at the once we need to complete the simulation, then we will be having a clear idea on how much energy it was consumed at the end of the day. Like we can calculate that also. And there is one more thing here in the user interface. There is a display. I hope I have explained you, but still I am telling you. So if I click this display and place here, there is a display icon, and I am going to drag this mission and drop on the display. Number of parts entered into that mission will be directly visible. Click and drop and drag and drop. Like for the drain also, instead of going for directly to the statistics, I can directly use this display and drag and drop. I can re-increase the speed. After 10 hours I can directly check how many parts I have produced. So this is the parts I have produced. Clear, sir?
Clear, clear.
Okay. Now there is this Sankey diagram also. Sankey diagram is for flow of the product. So how the material movement is there, how the material flow. So how the material from this position, how the material is moving, from which direction to which direction, from which machine to which machine it is flowing. To check that one, we can use this flow. We can check this. Just a second. Sankey diagram. Let me close it. Once the simulation was done, then I need to open and show. This is what the Sankey diagram is, which means material flow rate. In this middle direction, the material movement is more, huge when compared to the rest. Why? Because here I have changed the processing time to 1 minute. So here, so the material movement will be less. The subsequent mission see, there is a light thin yellow green color line is there. Whereas this one, there is a thick line is there, which means the material movement is when compared to this one, it is more. Again from this it was diluted, half will be given to this, half will be given to this. Again from this it will be diluted. Here there will be joined, here this part will be and this part will be joined, thicker line. Again same, this line and this line will be joined, here there will be a huge line. Same from this one, after this mission the part will be distributed to two different lines. Finally it is reaching the here, there is a thicker line here. So Sankey diagram is for material flow, to check how the material movement is happening in the station, in the complete layout. Clear, sir? These are all
You
some
can,
of
yeah, yeah, understood the process. Can you show me how to assign Sankey?
assign Sankey. Okay, fine.
Understood the process.
Simple thing, sir. We need to click on Sankey diagram and hold it. That's it. We need to reset the simulation, run it completely. The simulation need to be stopped. See, once the simulation was done, then right click, show. That's it. There is no need of assigning, no need of dragging and dropping here.
Oh, understood, understood.
So these
Only
are
for energy we need to drag and drop.
energy as well as charts.
Okay. So if you want, suppose you can consider that there are some 100 machines.
Huh.
I want to check power consumption of all 100 at the same time.
Huh.
So is it possible?
Yes, sir, possible. But what will be happen? There will be a mess. That is why, out if there will be having 100 missions, I will be consider them as a 4 units or 5 units, considering 25 missions apart. 25 missions will be like a one process, and I will be collecting the information for the 25 missions in a single side. So it will be easier for me to track if it is in batch. Even for 100 I can collect. Now see, there are complete missions will be there, I can drag all the missions and I can drop here, it is possible. But what will be happened here is, I can't define where exactly the process is there. So if there is a power failure is there, where exactly that was I can't define with this direct one. So if it is having individual one, if at all I'm having individual thing, like for 10 missions there will be energy utilizer, for 20 missions there will be energy utilizer, for all the conveyors I am utilizing some energy utilizers, for all the buffers I am using some energy utilizer, then it is easier. Now, and one of the last
Understood.
thing is HTML report. So whenever we have done the model, we have to we have to present a report, or we have to showcase a report for that. So there is an option called HTML report in user interface. Just beside this one, comment, a display, chart, Sankey, then there is a HTML report. So we need to select the HTML report and drop here. Okay. Once the model was done, only after the model only. So we have to run the simulation, let it complete. So once the simulation was completed, then only we need to click show. Then we will be having a report like this. So here, what is the model name, what is the simulation root, which is nothing but here the subfolder folders, and simulation time, how much time the simulation is, starting time, end time, generated at what is the time. So we have to define the time. So this is the time 2022 1639 is the report I have prepared, and this is the model layout, and how many missions and mission characteristics. So what is the utilization, how much blockage, how much failure, drain, these are drain characteristics. Like, I can involve all these things in this plant simulation. Clear, sir?
Yes, I
If at all
understood.
I want, I can directly download this file and I can share it with the person, whoever so want. Here, there is a save option, print option. With these things, we can directly calculate. That's it, sir. These are the open
Giving
tabs.
shop floor, the output, this Excel sheet here, floor, which you have shown now. Is there any post processor kind of thing here?
Post processor for what purpose, sir? No, no, no.
No, just I'm asking.
No, 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 sir. In CAM, in robotics, we will be having post process. Why? Because there is a coding purpose is there. There will be connectivity is there. Controller is there. Here, there is no any connectivity controllers. So there is no any post process for this one. So we have to create the virtual layout and we have to check all the results virtually itself. And only physical document that is visible is this HTML report.
Okay, this report is an output for
Yes,
customer,
this
no?
report is the final output. So whatever
Final
the
output.
station we are preparing, so this will be our final output. So here, see, overview, model, drain statistics, drain, everything will be defined here. So with this, we can do the model. Just a second, refresh this report, open the print preview, save. Yes, sir, that's it. So this is what exactly the report is explaining. So with this report, we can define, there is one option, sir. I hope, what happened to the software? There is one option where we can change this name also. In the end, there is a name John D. So this is the software person's name, I mean the person who has built the software, his name. So we can modify that name, we can modify it with our name. For that there is an option, but it is right now, I don't know, it was stuck. It's not. Points are clear.
Yeah, I got it, got it.
Yes, sir. These are
So
the
we have a,
basic tools. Yes, sir. These are the basic tools in the plant simulation with which
okay.
we are going to run. Yes, it was open. In the HTML report, right click and there is this open tab. In that open, see here. In the end, there is one thing, John D. Yes. In the last, there is a John D option is there. Here, you can delete it or you can use. I don't know if it will come or not. Apply, OK, and I will be show. Yes.
Okay, got it.
So these are the basics of the plant simulation, sir. With this, we can create any type of layout and we can start working on it. So while working, automatically some problems will automatically be solved. So all these confusions will going to erase when we start working on the different models. But this is the basic. This is what exactly the tools will be. Major tools that will be used in the plant simulation will be these tools only. So whatever the tool we are using, whatever the model we are using AGV, we are using a robot, whatever, this is the basic thing. So if at all I'm using a robot, then what is the method? If at all I'm using a conveyor, what is the method? What are the type of conveyors I am going to use? If at all I'm using a AGV, then what is the method for using this one? So if I using a station, then what are the different parameters I need to consider for using a station? So first thing is a processing time, second one is a failure time, third one is a energy, fourth one is if at all I'm using a human, then how can I supposed to import a human to this thing? These are the default things that will be used in the plant simulation, sir.
Okay, understood.